Namaste friends. Today we will going to discuss the Meselson and Stahl experiment of DNA replication. Before going into the details of that experiment, let us have a quick historical aspect of replication. Two discoveries in the 1950s had revolutionized the details of molecular biology. First one is the discovery of genetic material, and the second one is the structure of DNA itself. Early in 1928, Griffith discovered the famous transformation experiment and hinted that DNA can act as a genetic material. Later in 1944, Avery, MacLeod and McCarthy extended the Griffith experiment and solidified the evidence that DNA can act as a genetic material. Simultaneously, research was also going on the chemical structure of DNA, and in 1950, Franklin and Wilkins obtained the X-ray crystallographic structure of DNA and postulated a double helical structure for it. Finally, Hershey and Chase used radioactive substance and confirmed that DNA is actually the genetic material. At the same time, in 1953, Watson and Crick put forward the detailed molecular structure of DNA to the world. So, if DNA is a genetic material, then it has to pass from one generation to another, and therefore it must be duplicated or replicated. But what is the mechanism of that replication? In 1956, Kornberg discovered the DNA polymerase enzyme from E. coli, and just 2 years later, in 1958, Meselson and Stahl finally solved the mystery of mechanism of DNA replication. So before going into that experiment, let us have a quick theoretical view of types of DNA replication that are possible for DNA double helix. In the conservative type of replication, both strands are conserved in one offspring, and a second double-stranded DNA is somehow synthesized in other offspring. Whereas in the case of semi-conservative replication, one strand of parent is conserved in both offspring, and a new daughter strand is synthesized from this. While in dispersive, also known as non-conservative replication, the parental strand is degraded to nucleotides, and again a new DNA synthesized in the offspring. During Watson-Crick study on DNA structure, Crick suggested that double-stranded duplex DNA must replicate using semi-conservative type of replication, but he was not able to give any experimental proof, and therefore Meselson and Stahl's role comes into play. Now let us consider or discuss in detail their experiment. Meselson and Stahl actually use cesium chloride density gradient centrifugation technique, where cesium chloride is dissolved in water and spun at very high centrifugal rate to produce a gradient. If we look at the chemistry of cesium chloride and water, we can see that the atomic mass of cesium ion is 133 and that of chloride is just 35. We also know that water is a universal solvent. Why? Because water has a high dielectric constant, which is the number of dipole present in a molecule. In case of water, the dielectric constant is 78.5, which is quite high. That is, there are two dipoles present per molecule of water. Cesium and chloride are bonded together by ionic bond, where cesium has delta positive charge, whereas chloride have delta negative charge. So, how cesium chloride is dissolved in water? Due to the high dielectric constant of water, water shield cesium chloride attraction and replace the solute-solute interaction with solute-solvent interaction like this. Cesium interact with the oxygen of water while chloride interacts with proton of water, thus forming a uniform solution. This is actually the basic principle behind the dissolution of all ionic or polar solutes in water. If this uniform solution is placed under a high centrifugal force for a very long time, for example 1,40,000 rpm for almost 2 days, due to the low atomic mass of chloride ion, it do not experience a high centrifugal force and remain present in a uniform state. And we can see that these red dots are uniformly present, whereas the heavy cesium ion experiences a high centrifugal force and thus forms a gradient from top to bottom. We can see that these blue dots are less in upper part, whereas more in the lower part. So we can say that the upper part have low density of cesium ion, say for example 1 gram per ml, whereas the lower part have a higher density of cesium ion, for example 1.8 gram per ml. Meselson and Stahl actually use 6 molar cesium chloride concentration, as its density is similar to the density of DNA, which ranges from 1.6 to 1.8 gram per ml. Coming to the next part of experiment, we know that to culture the bacterial cell, we have to add some nitrogenous source, mainly in the form of peptone. But Meselson and Stahl actually use two different radioactive forms of ammonium hydroxide. First one is the normal light NH4OH, which contain N40 nitrogen, whereas second one has radioactive heavy N50 nitrogen. So what they did, they first grew E. coli for many generations in N15 containing media, so that all the nitrogen containing biomolecules get labeled with it. Then they changed the media with light N40. So according to the semi-conservative replication, the offspring now incorporate N14 in new daughter strand while retaining the N15 from parent. Now in the second generation, these act as a parent and therefore pass one N15 strand to one offspring and other N14 strand to other offspring, both of which synthesize new strand in N14 form. Same thing again happens in the third generation also. We also know how to calculate the number of offspring in bacterial cell after 3 generations using this formula, where n is the number of generation. So we can calculate and obtain 8 offspring from one bacterial cell after 3 generations of binary fission. After this, Meselson and Stahl then extracted the DNA from these samples and spun it in cesium chloride density gradient column. We can see that the parent have both N15, which is heavy, so DNA gets settled somehow at the lower part of the column. DNA from first offspring contain one heavy and one light chain, that is the hybrid DNA. So it forms here in the middle part of the column. Likewise, F2 and F3 also forms 2 bands corresponding to the hybrid and light DNA, although F3 have thicker upper band of N40. That's all, friends. Thanks for watching, and if you have any question or suggestion, please write to us. I would be glad to answer that. Thank you.